Hey trig class, we're going to look at this problem from the 8.6 homework set. We got a tangent 2 theta, but a cosine of 1 theta, and we're looking for 1 theta in 1 revolution around the unit circle. So I'm going to start here with the tangent 2 theta, and I'm going to rewrite that as the sine 2 theta over the cosine 2 theta. And the reason I'm going to do that is because I want to try to get a single expression, like combine these together into a single expression. And then because it's equal to 0, then the numerator would have to be equal to 0 in that case. So I'm going to add the 2 cosine theta to that. And to get this to work out, I need a common denominator. So this already has the denominator of that cosine 2 theta. And I'm going to make that be the denominator. Again, think of this as just like over 1. I'm multiplying the 1 times the cosine of 2 theta. So I need to multiply the top by that as well. Now that I have a common denominator, I can combine these into a single expression. Alright, if a fraction is equal to 0, then its numerator is what's equal to 0. So the next step, I'm just setting the numerator equal to 0. Alright, now to be able to do something with this, I'm going to switch this to 2 sine theta times cosine theta. Alright, that's again what sine 2 theta is equivalent to. And then I'm adding to that the 2 cosine theta times the cosine of 2 theta. Now if you look, we got a 2 cosine theta here, we got a 2 cosine theta there. We can factor that out. We end up with that expression. Now we have two equations here. Because this is multiplication set equal to 0, the 2 cosine theta could be equal to 0, which implies just the cosine is equal to 0. Or this equation, sine theta plus cosine 2 theta, could be equal to 0. And this is one where we would need to split cosine up into, because in this other one is sine, 1 minus 2 sine. And then we still got a sine theta here. Alright, I got negative 2 sine squared theta. I got a sine theta in the middle, and then I got a plus 1. I'm just rearranging this to be in descending order of the signs. Alright, now if you look, I've got a negative 2 right here. So these two numbers, whatever they might be, need to multiply to negative 2. I also have 1 right here. So these two numbers have to multiply to 1, so obviously it's going to be 1 and 1. It's just now we have to get the signs correct, okay? Because whatever we have here outside, whatever we have here inside, those have to combine to a positive 1 sign. So that means, if you kind of follow along, this would have to be a positive 2. This would have to be a negative 1 to be positive. This would need to be positive. All right, and now if you multiply it out, this times this would be negative 2 sine squared. Outside I'd have a positive 2 sine. Inside I'd have a negative sign, which combines to a positive sign. And then last is positive 1. So there's how this would factor. And now each one of these would need to be set to 0. So 2 sine theta plus 1 could be 0, or negative sine theta plus 1. Solving this for sine theta, I'd have sine theta is equal to, move that 1 over, divide by 2, I'd have a negative 1/2, or moving this over, I'd have sine theta equals 1. Alright, and now we look at all our possibilities. Unit circle. I need to find where is cosine equal to 0. Cosine is the x-coordinate, so that happens at pi over 2 and 3 pi over 2. So there's our first two choices. So that comes from the cosine function. Alright, now the sine equaling negative 1/2. Remember, sine is the y-coordinates on the unit circle. So we want the y-coordinate to be negative 1/2. So that happens here at 7 pi over 6. That also happens way over here at 11 pi over 6. So 7 pi over 6, 11 pi over 6. Alright, and then here, where is sine? Where's the y-coordinate equal to positive 1? We see that also happens at pi over 2, but we've already done pi over 2. So that's nothing new there, so we don't need to include any additional information there. So that's pi over 2, but that's already happened. So our solutions, our possible solutions, in between 0 and 2 pi are those, okay? Pi over 2, 7 pi over 6, 3 pi over 2, 11 pi over 6 in order. Alright, so I strongly encourage you on something like this to go in and graph it to make sure you've got all the right values. I'm going to clear out these functions. Alright, so again, just using x in place of theta, graphing that. The right hand side is 0, so I don't have to do y equals 0. I can just graph it. Let me just do the window that we have from 0 to 2 pi. Alright, again, I like to make this go up in pi over 6, so I can just count off the little tick marks is pi over 6, 2 pi over 6, which is pi over 3. My y minimum, I got a tangent in here, so I can go off to infinity. So let's make this go to negative 10 to 10. All right, and let's look at our graph. So you can see there I am crossing the x-axis at certain places. What I can do in this case is do second calculate, and I want to find my zeros, okay, because it's equal to 0. So that's going to be option 2. All right, now I'm going to scroll way over here to the very first one that I see. Left bound, so that's roughly where I'm seeing it, but left bound means go a little bit to the left of it where you're below, so your y coordinate's negative, and then go to the right side where your y coordinate becomes positive. You can see now we're definitely positive. And then guess about where do you think this 0 is occurring, and there's my guess that it comes up with. All right, so there's 1.5708 roughly. But remember that value x, once I've done a calculate, that value x is stored as this x button. So if I take the value of x, right, and remember that's one of our answers. If you scroll way down here, that's that pi over 2. If I take that x and divide by pi, I should get something very close to a half. Now this is an approximation, so it might not be perfectly a half, but I can see that there's pi over 2. All right, I can do it again, calculate the 0, and now I'm going to make my way to the next one, which is over here. So I scroll way over here to the next 0. Again, left bound means you need to be below it or to the left of it, to where in this case, the y coordinate will be negative. All right, I'm going to come back to where it was. Right bound means go a little bit to the right. Maybe not that far. All right, and then guess means get as close to where you think it crosses as possible. So that's pretty close. All right, so hit enter on that guess. There's what it gives me. All right, once again, that is stored as x. X equals that. So I can go second quit x. And then I'm going to do divided by pi. I'm dividing out the pi, and then I'm going to change that into a fraction. All right, and so it gives me, when I do this, hit enter, 7/6. So put the pi back in, that's 7 pi over 6. All right, and then you can do that for all of these. I'm going to do it for one more just so you can see it. Finding the 0, scroll over a little bit more. There's approximately where it's happening. Left bound means go to the left of it, get a negative in this case. Right bound means go a little bit to the right of it. So we cross over, now we're positive. We want a sign change between left bound and right bound. And then guess is right around there. So there's the number that it gives me. That's stored as x. I'm going to go to quit, divide x by pi, and then store that as a fraction. So you can see 3 pi over 2. So anyway, that is the solutions. The last one will be 11 pi over 6. That is a way that you could use your calculator to check those answers.